Hey, all you cool cats and kittens. We are going to look at area of regular polygons with circles. So we're just combining what we learned for day 3 and day 4. Um, you're going to find the area of two shapes and subtract. Okay. So for number 1 and number 2, you are looking at the area of the circle, minus the area of the, what's that, a square. Okay. So let's find the area of a circle. It says this right here. We know it's a square because it's fitting inside of a circle. It has to be a square. We know that the radius of the circle and the diagonal of, or half of the diagonal of the square is 12 meters. And that's all we know. Well, we know a little bit more than that. We know that this is the radius. So to find the area of the circle is going to be pi r squared. And we know that that is going to be pi r, which is 12 squared. And we're going to subtract that from the area of a square. Well, how do we find the area of the square? We need to find the side. And we know that once we find one side, we'll have the other side. So there's one of two ways we can do this. We can find this little one and multiply it by 8, or we can find this big one and multiply it by 4. That's either way, it's pretty easy because we know that these angles are going to be 45 degrees, either one that we use, because it's half of this angle, which has to be 90. So the way it is in your notes is we went ahead and doubled this length to find the diameter, which is 24. And we know that this is x, and this diameter must be x root 2. So I know that 24 is equal to x root 2. So I'll divide by root 2 on both sides to find my x. So this is the length of one of the sides. And there's 4 of them, or not 4 of them. There are each side here. So I'm going to multiply that by itself. So 24 over root 2 times 24 over root 2, which is 24 is 576, and root 2 times root 2 is 2. So 576 divided by 2 is going to give us 288. So minus 288. All right. So we have pi 12 squared. So pi times 12 squared, and then minus 288. And we get 164.4 meters. So this total area of the shaded region is the area of the circle minus the square that's been cut out on the inside, which is 164.4 meters squared. You do the same thing for that area of the triangle. We know that it's an isosceles or a equilateral triangle because all sides must be equal to fit inside of a circle. So I'm going to skip ahead. You do the opposite version of that for number 3. It has to be an equilateral triangle because it has a perfect circle sitting inside. It gives you the apothem of one of those, so it's easy to find all the other stuff. Same for number 4. It gives you an apothem, so you find the radius and so on. Let's go on to sector segments, area of a segment. So what is a segment? Well, this is a sector. Okay. Well, this is a segment. It's a portion of the sector. All right. Now, how do we find that? Well, we find the area of the sector, and then now we have a triangle cut out of that sector. Okay. So we have to find the area of the whole sector and then find the area of the shape that's been cut out of it, always a triangle, and we subtract the two. Okay, so it's area of the sector. Remember, a sector is the whole piece of pi minus the area of the triangle. And that will give you the area of the segment. Okay, That'll give you the little slice. That'll give you the crust of the pizza. Okay. All right, let's do number 5. Number 5 says we have a circle. We know that the radius is going to be 6. We know that this is 120 degrees, and it wants to find the shaded area, that segment right there. So we're going to find the area of the whole sector, which if you remember from our notes, from day 3 notes, we know that area of a sector over area of the circle is equal to degrees of the sector over 360. Okay? So we know that this one has a radius of 6. We know that the area of the sector is going to be pi 6 squared, set it equal to 120 over 360. Cross multiply. So we're going to multiply this value by 120, then divide it by 360 to find our area. So pi 6 squared times 120 divided by 360. And that will give us this area of that sector was 37.7. Okay? 37.7 units. It doesn't say. So that is the area of the sector. Now we got to find the area of the segment, which means we got to cut out that triangle, which is 1/2 base times height. Okay? So we need to find this height, or 1/2 base times height. We need to find this base and that height, or we have this base and we need to find this height. Okay? So let's do it that way. We know that has to be, let's see, I'm going to do it this way. This is 60 degrees because I know it's got to be a perpendicular bisector. And that makes a 30, 60, 90 triangle here. That makes it easier for me. 60 degrees is here. 30 degrees is here. Opposite 90. We know that this is going to be 2x. We know that this is x. And we know that this is x root 3. We have no real interest in, we need to find the height and we need to find this base. So we need to find that and then multiply by 2. Okay? So that our hypotenuse divided by 2 will give us our x. So we know that our apothem, or our height, is 3. And we know that our base is going to be 3 root 3, but there's 2 of them. So that's 6 root 3. All right? So we know that it's 1/2 our height times our base. So we're going to do 37.7 minus all of that, which is 37.7 minus 0.5 times 3 times 6 root 3. And we're going to get 22.1 units squared. Okay. Let's skip ahead and let's see. We'll do number 8. Number 8. It has a semicircle. Then it has a hexagon. Then it has a trapezoid. Okay? It says the height of this trapezoid is 19 centimeters. It says the base of this trapezoid is 15 centimeters. It says that this hexagon is a regular hexagon. And it says that one of those sides is 9 centimeters. Let's see, 9 centimeters. And then it says, that's about it. So we know that the diameter of this circle is 9, so the radius of the circle is 4.5. So find the area of this circle. It is pi r squared divided by 2 because it's only a semicircle. So I know that that is going to be pi times 4.5 squared divided by 2. And that will give me 31 and change. So 31.8. Let's call just this area, just this portion, 31.8. And we are in centimeters squared. All right. We know that we need to find the apothem here. We know that our whole length here is 9. So I know that it is 1/2 the apothem times the perimeter. I know my perimeter is going to be 9 times 6, which is 54. And I know my apothem is going to have a right triangle here. This is going to be 4.5. I need to find this internal measure. It is 6. You remember we need to find our central angle, which is 360 divided by 6. Then divide that by 2. So I know this is 30 degrees. That's 4.5. I want to find my apothem, though. I have opposite and adjacent. Opposite and adjacent is TOA, so tangent of 30 is equal to opposite over adjacent. So multiply both sides by a, then divide by tangent of 30. So a is equal to 4.5 over tangent 30. 4.5 over tangent of 30. So that gives me 7.8. So I know that my apothem is equal to 7.8. So 1/2 times 7.8 times, what was that again? 9 times 6, which is 54. So 0.5 times 7.8 times 54. It's going to give me 210.6. Then, oh man. Did I mess up? I don't know. Let's keep going. Plus area of a trapezoid, which is 1/2 base 1 plus base 2 times height. Base 1 is 15, base 2 is 9, and our height is 19. So 1/2 times 15 plus 9 times 19, which is 228. Add them all together. And I get 470.4 with a margin of error from the notes, which is fine. All right. I hope this helps. If you have any questions, please ask in the comment sections. Also, I'm releasing all of the videos and all of the lessons and everything on Monday. It's up to you to do it at your own pace. Today, the review is available, the quiz is available, everything is available. Sorry, I can't put a quiz in the Google form. You'll have to take a picture. And that is all. All right. Review tomorrow. And if you have any questions, let me know. Test is on Monday. You have a great, wonderful day.